to set things up. Okay, I bet for some reason I am just betting a laptop would be probably the better place to go. Meanwhile, let's just see. Let's go to home, get test manager while we're doing that. Go all the way down, there should be some extra. Not there. But there's other places I can go. Okay, if you could pull your quiz up too, because there's all kinds of problems, and he may have had all different ones assigned to you, or maybe not as many different ones assigned to you. Okay. I'm in my office. Yes, that's one way. Well, I've got a class at 10. I will be in at 1 over at the Center for Academic Success. Okay. So let's see. So it's getting blocked. Let's just talk on the phone, okay, for now. And we can maybe later work that out, but realize that one thing is maybe changing browsers or whatever, but having access to Google Hangouts would be nice. Okay. Yeah. Okay. So did you have problems like, let me see if this problem sounds familiar. Okay, let me find the problem. Jack usually mows his lawn in 3 hours. Marilyn can mow the same lawn in 7 hours. How much time would it take for them to mow the lawn together? But that sounds like a familiar problem. You understood rate problems. Good. Okay. So I'm going to then go, yeah. Okay, here's the next one I'm going to try on you because I have some things up, and so you're okay with what are called motion and work problems. Okay, so that's fine. Next type, but in 7.7 there's different types of word problems. So ones that have to do with motion and work, that seems to be, you get the idea that what you do is figure out the rate, and then the rates add is basically what happens. So you go 1 over, and then you add the reciprocals, and then you go back and figure out what the question is. Okay, so the next, there is a phrase, X varies directly as Y. Do you know what that sentence means? Yeah, so it basically means X equals K times Y. And the fact is, then they give you a second fact, that X equals 6 when Y equals 3. So what I want you to write down after X equals KY is 6 equals K times 3. Okay, well, how would we find out what K is equal to? Divide both sides by 3. And so we've got K equals 2. So with that piece of information, the next thing you write, right below that is X equals 2Y. And then we are asked to find X when Y equals 4. Yeah, X equals 2 times 4, or 8. Okay, that varies directly. Okay, and so let me just enter that. Check answer. Good job. Okay, the next type of thing, let's just see. Direct variation problems. And direct variation, I think, is always just that. The next thing you got to be able to do is tell the difference between that and what's called inverse variation. Okay, so if they say X varies inversely as X or as Y, what that means is Y equals K times 1 over X. So it's translating those two expressions. What X varies directly as Y means Y equals KX. X varies inversely as Y means Y equals K times 1 over X. And then you start taking the information to solve. So if X equals 50 or Y equals or Z equals 50, no, Y equals 50 because I wrote it differently. Y equals 50 when X equals 5. Find Y when X equals 6. Okay, well, I've got Y equals K times 1 over X. That means I have got 50 equals K times 1 over 5. Multiply both sides by 5. 250 equals K. Here's my K. And I've got Y equals 250 times 1 over X. But my 1 over X is now 1 over 6 if I want to find it when X equals 6. And so 250 over 6 is something like 41 2/3. Does that make sense? Okay, yeah, so. Okay, let's just see. Yeah, so it's basically to realize there's two expressions you need to know. Before writing the variable, substitute, find it, K, finding your equation, unknown. So let me see, I did something wrong there. We did something wrong, so let me see. 50 when x equals 5. K of 5, 250 equals K. So 50 K over 6, 250 over 6. Let me just do something here. For some reason, hold on, what did I just do? Try again, clear this out. 250 divided by 6. Yeah, 41 and 2/3 is my answer. And so let me see something here. Oh, I see. I didn't do an inverse variation problem. I picked one that was a direct variation problem. Inverse variation. Okay. So here's an inverse variation problem. If the temperature is constant, then the pressure of a gas in a container varies inversely as the volume. So pressure varies inversely as the volume. How would I write that sentence, first of all, as, in terms of letters? Pressure varies inversely as volume. You could call it Y. So we'd have to name it. So pressure, let's just say pressure is Y. So Y. Yep. K times what? Okay. So X equals volume, and you've got your equation. Y equals K 1 over X by translating that expression. Now, if the pressure is 50 pounds in a container with 9 cubic feet, what is the pressure in a container with 7.5 cubic feet? So let's unpack that. If the pressure is 50 pounds per square foot in a container with 9 cubic feet. Okay, so what do I do with that piece of information? Yep. Yep. Okay, and so what do I do with that piece of information? Yep. And so what am I left with? Yeah. So what is 9 times 150? 9 times 50 is? Okay. So now I know that K is 450. What is the pressure in a container with 75 or 7.5 cubic feet? That's my next question. What is the pressure in a container with 7.5 cubic feet? What do I do with that? Okay, can we do anything else with that though? There we go, 450 times 1 over 7.5 equals y. And tell me what y must be then. Times 7.5? You wrote the right thing. It's y50 equals y equals 450 times y equals 450 times 1 over 7.5. You said y equals 450 times 7.5. It's 450 times 1 over 7.5. $60 exactly. Okay, let's try it. I'm going to hit enter. Excellent, it says. So that's inverse variation. Okay, so you got to realize how to set up direct variation versus inverse variation. Yes, that's what it will say, and you've got to translate that. And now there's this idea of a joint variation. And I'm going to admit something, right? Offhand, I'm forgetting what joint variation means. So we can find out that quick. J implies that J equals, then now remember, if you're varying jointly, it's usually with two other variables. So J varies jointly with K, with G and V. That means Y equals K times G times V. G and V say. So let's say Z, let's go X, Y, and Z just so you get used to it. Z varies jointly with X and Y. That means Z equals KXY. And see, you know how to, probably I betting you know how to find the constant of variation first by essentially plugging in everything you've got. And then you find out, you know, the new situation by plugging in what's in the new situation and remembering your new constant variation and figuring things out. So that's that. I've got about 10 minutes left is why I'm not going to go through that whole thing. So there's 4 of them, and then finally it's combined variation. Let's see what we mean by combined variation problems. Well, that means they're going to have some sort of, you know, it's maybe going to vary directly with one thing and indirectly with the other, and you just start realizing you make that translation. Direct variation means y equals kx. Indirect variation or inverse variation means y equals k times 1 over x. Joint variation means y equals k times x times z. And then you start with that, and that's the main piece of information, and you go through and figure out what you figured out. So I think the next best thing at this point is for you to finally be able to get a hold of those assignments again, get back on Access, and see if just that piece of information helps you through it. Okay, see if that helps you. Do you know, by the way, how to use the Help Me Solve This button and the View an Example button? Okay, so that should hopefully help. But that's just this key things that hopefully those 2 things would have told you. But yeah, anyway, that's what I do is try to get to assignment when you can, and see if just the little bit of talking we've done jars what you need jarred on that. All right, great. Thanks. Take care. Bye-bye.
Right, what that did is you be listening to music.